Hello, today I will be spreading some light on the understanding of degrees of freedom. Look, degrees of freedom is an important topic. As far as the research area is concerned in social sciences, degrees of a clear concept over the degrees of freedom concept you should have. In this lecture, I try to clarify what is the degrees of freedom. Now look, degrees of freedom refers to the maximum number of a logically independent values, which are values that have the freedom to vary in the data sample. We can say in such a way that how many values involved in a calculation have the freedom to vary. How many values do have the freedom to vary? This is the matter of degrees of freedom. Now, with a simple example, I try to clarify the concept. Suppose there are five positive integers. There are five positive integers, and among these five integers, there are four unknown. What are those? 2, 7, 6, and 5. You have five integers, and you have the information that there are 2, 7, 6, and 5. And also the average of the entire data is revealed. That is 7. That is 7. As the average is 7, so the total number is 35. The total number is 35 because there is 5 positive integers. Now, as you know, the 4 integers, that is the 2, 7, 6, and 5, the sum of these is 20. The sum of these is 20. So what remains? The remaining number is 15. So the last one, the 15 number, does not have any variation. It can be nothing else. It can be nothing else. The fifth number has to be 15. There is no other ways. It can be nothing else. It does not have the freedom to vary. Here is the problem. It does not have the freedom to vary. So we have five integers and one number, that is the 15, which does not have any freedom to vary. So degree of freedom, what is the degree of freedom? So degrees of freedom here is 4 because one does not have any freedom to vary. So in this example, when there are five positive integers, the degree of freedom is 4. Okay. Now, degrees of freedom calculated for the special statistical validity. For the statistical validity, degrees of freedom can be calculated, such as chi-square test, t-test, and advanced F, test. You have this type of tests you can, and here is the role of degrees of freedom. And degrees of freedom has the contribution to the validity of an outcome. Degrees of freedom has the contribution to the validity of an outcome. Now, if you consider here, I have mentioned the in this slide you can find the rule of degrees of freedom, the formula for degrees of freedom, that is df equal to n minus 1. Here df is the degrees of freedom and n is the sample size, the total number. In our previous example it was 5, so 5 minus 1 equal to 4. So when there is 5 integers, there is 4 degrees of freedom. Now, as I have mentioned that the degrees of freedom is very much useful in chi-square test and t-test. For example, suppose, take an example, there are a new drug which is invented, and patients receiving the drug would show increasing heart rate. Okay, increasing heart rate. Patients who received the drug would show increasing heart rates, but the patients who does not receive the drug would not show any increasing heart rate. Their heart rate is normal. So, in this case, the chi-square test has an important role. Whether the difference in heart rate is considered significant, whether the difference in heart rates, that is the patients who received the drugs showing the increasing heart rate, and the patients who does not, the patients who do not receive the drug does not show the abnormal heart rate, that is their normal heart rate. So here is the difference, the increasing heart rates and normal heart rates. So whether the difference is in heart rates is considered significant, chi-square test has an important role. If the observed data and the estimated data, if the difference between the observed data and the estimated data is large, then we can say that the chi-square test is insignificant. Okay, the chi-square test is insignificant. And if the difference, that is the difference between the observed data and the estimated data, then if it is small, the difference is small, then it is significant. The chi-square test is significant. If the chi-square test is significant, then the null hypothesis is accepted. Whatever is the null hypothesis, it would be accepted if the chi-square statistics is significant. So in this example, whether the difference in heart rates is considered significant and degrees of freedom are part of calculation. Why? Because degrees of freedom identify how many values in the final calculation are allowed to vary. How many calculation, how many values in the final calculation are allowed to vary. So degrees of freedom has the contribution to the validity of an outcome. As in our previous example, there is 5 integers and 4 is the degrees of freedom. So degrees of freedom has an important role. Now look, this is the chi-square. This is the chi-square formula, where Fi is the observed frequency for category I and Ei is the expected frequency for category I based on the assumption that null hypothesis is true, and K is the number of categories. Okay, K is the number of categories. This K here, K minus 1 is the degrees of freedom. Here the chi-square test with K minus 1 degrees of freedom. So degrees of freedom here in chi-square test is K minus 1. So degrees of freedom has the contribution to the validity of an outcome. We should take another example. Suppose there is a hospital and there are 3 categories. There are 3 categories among patients: serious, stable patient, serious patient, and critical patient. So there is a hospital and there is an emergency section, and there are 3 type of patients. For the first type is the stable patient, the second type is serious patient, and third type is critical patients. So category 1, category 2, and category 3. Here is the 3 categories. Okay. So in this equation, K equal to 3. If you like to find out the K square, then here K is the 3. Now, considering the last year observation, the hospital authority found it that there are 50% stable patients, there are 30% serious patient, and there are 20% critical patients. So 50%, 30%, and 20%. This is this percentage, that is the 50, 30, and 20 are the observed. This is the percentage. And suppose the hospital authority has selected 200 patients who have been who have been treated who have been treated and on the basis of the record there is they on the basis of the record, that is, I have mentioned that the 50% is stable and 20%, 30% is serious and 20% is critical. So 100, 100, it means the 200 multiplied with the 50%, it is the 100, and 200 multiplied with the 30%, it is 60, and 200 multiplied with the 20%, it is 40. So 100, so 160 and 40 is the estimated frequency. Is the estimated frequency. Here EI represents those frequencies. Okay. I hope you got the point. And FI is the observed frequency. So hospital authority has collected 200 data, and among the 200 data, the stable patients is 98 and serious patient is 48 and critical patient is 54. So 98, 48 and 54. In category 1, the observed data is 98. In category 2, observed data is 48, and in category 3, observed data is 54. Okay, the total is 200, and the estimated frequency is 160 and 40. So here the difference between the observed data, that is 98, 48 and 54, and 100, and this is the observed data, and the expected frequency, that is the 160 and 40. Whether the difference whether the difference in the in the categories is considered significant, is tested can be tested by the chi-square formula. This by the by this chi-square formula. Okay. So when we use this formula, we should consider this case. We should consider this case, and this k is the number of categories, and so the test statistics has a chi-square distribution with k minus 1 degrees of freedom, So degrees of freedom has the contribution to the validity of an outcome. If the degrees of freedom is high, then it is good. And if the degrees of freedom decreases, then it is not suitable for a statistical result. So overall understanding is that The degrees of freedom is an important topic in, in statistics, especially in the research of social sciences. You should have a clear idea on the degrees of freedom. So, in this lecture, I try to clarify the degrees of freedom, and I hope you got the crucial point and enrich your knowledge. And thank you for enjoying this lecture.